Hi and welcome. I am trying to learn particle physics, today quarks, and after we've done it, we're gonna do a bit standing yoga. And if you participate in the standing yoga, then it's at your own risk. And this is part 6 or 7. Working out where they come from is another matter. Down quarks are slightly heavier than up quarks, but don't expect the neutrons 2 down quarks versus the protons 1 to explain the neutron's sliver of extra mass. The neutron has 0.1% more than the proton in mass. Both quarks' masses are tiny. It is hard to tell exactly how tiny, since quarks are never seen singly, but the up quark has a mass of something like 2.2 MeV, mega electrovolt. The neutron itself has around 1000. So the up quark has 2.2. A sliver under 4000 billionth of a kilogram. So they're very light. And the down quark may be double that. That is just a tiny fraction of the total proton and neutron mass. So what we're saying is the neutron has 3 quarks in it, up, down, or something like that. But these 3 quarks in them just have around 10-15 mega electrovolt at mass, but a whole neutron has 1000. Like all fundamental particles, quarks acquire their masses through interactions with a sticky, all-pervasive Higgs field, that thing that makes the Higgs boson. Here, don't get that part. There's some of the Higgs field, and there is the Higgs boson, and that helps to give a quark's mass. But explaining the mass of matter made of multiple quarks clearly needs something else. The answer comes by scaling the shear cliff face that is quantum chromodynamics. Okay, let's do that. Just as electrically charged particles can bind together by exchanging massless photons, color-charged quarks bind together to form matter such as protons. Photons are massless. How does that even is really important? Photons are massless. I don't get really what photons is, I said it already, but it has something to do with light. Light is massless. And they are doing quantum chromodynamics. And it has something to do with photons. These quarks are exchanging photons, which helps them to stick together. But these photons are massless, and therefore that whole thing works at all. But I don't get it. Just as electrically charged particles can bind together by exchanging massless photons, color-charged quarks bind together to form matter such as protons, and neutrons by exchanging particles known as gluons. They are exchanging gluons. The protons, the neutrons. Who knows? Electrically charged particles can bind together through photons, and these protons and neutrons bind together through gluons, but same system. Although gluons have no mass, they do have energy. A lot of it. Thanks to Albert Einstein's famous E=mc squared and the quantum uncertainty principle, that energy can be converted into a fluff of transiently existing quarks. I don't know the word for. And the antimatter equivalents beyond the free normally said to reside in the proton. Let's do it again. That energy, so they have energy. A lot of energy, no mass, but energy. These gluons which have the quarks inside of the neutrons and protons to stick together, when they are free in them. That energy can be converted into a froth of transiently existing quarks. I don't know the froth is, and their antimatter equivalents beyond the free normally said to reside in the proton neutron. Let's just read on. To try to make sense of this quantum froth. Over the past 4 decades, particle theorists have invented and refined a technique known as lattice quantum chromodynamics. In much the same way that meteorologists and climate scientists attempt to simulate the swirling complexities of Earth's atmosphere by reducing it to a 3-dimensional grid of points spaced kilometers apart. Okay, but what are we doing? They're simulating the swirling complexity of Earth's atmosphere, so there are a lot of clouds, by reducing it to a 3-dimensional grid of points spaced kilometers apart. Whatever, they're making a map of the world, of the weather. And now they're doing in lattice chromodynamics, reduce a nucleon's interior to a lattice of points in a simulated space-time tens of femtometers across. 1 femtometer is a millionth of a millionth of a millimeter. Okay, a femtometer is very, very short. It would be interesting if you press your hands together, if there's a distance between your fingers. And if it would be such like a femtometer. And out of what would it consist? And maybe it ends up with what we are defining as a finger. If people make these lie detector tests by measuring the amount of sweat on the hand, and also if people use touchscreens where sweat is used to transport electricity over current, so that means there's a tiny bit of water on top of the fingers. So basically the idea is, if the sweat is not seen as part of the finger itself, and there is a bit, is it already therefore not possible to completely bring the fingers together? Whatever, I just think the thought is interesting. Okay, where were we? Lattice chromodynamics reduces a nucleon's interior. Okay, we have an atom and we have the nucleon in it with the protons and neutrons in it. And that proton-nucleon bunch. To lattice, I don't know what lattice means. I thought that just lattice. I thought the salad thing, the thing to eat. But they're saying lattice, and a lattice is, I think, is a fence, or these things in a fence. Okay, interior to a lattice of points. Okay, I don't know what lattice means. Of points in a simulated space-time tens of femtometers. Wherever they're making a map of the nucleon. Quarks sit at the vertical of this lattice. At the vertices, I don't know what vertices are. Quarks sit at the vertices of this lattice, while gluons propagate along the edges. Whatever. The quarks are on the outside of it, and the gluons propagate along the edges of somewhere. By summing up the interactions along all these edges and seeing how they evolve stepwise in time, you begin to build up a picture of how the nucleon works as a whole. They're making a diagram, and somehow there are all these things, and they are running from left to right, and now we understand how these quarks inside of the protons are all together. Trouble is, I don't know the vocabulary. Even with a modest number of lattice points. What are lattice points? You say 100 by 100 by 100, it's separated by 1/10 of a centimeter. Okay, we're having a very detailed map. There is an awful lot of interactions. And lattice quantum chromodynamics simulations require a screaming amount of computing power. Okay, it's hard to calculate with fingers, not unknown. Complicating things still further, because quantum physics offers no certain outcomes, these simulations must be run thousands of times to arrive at the average answer. That's interesting. The quantum chromodynamics, it happens all the time differently. The gluons don't the same. And to actually find out what happens, after one run, we don't know how it actually works. So we do a second one, and the third, and a couple of thousands of them, so we have an average idea how now these gluons work. To work out where the proton and neutron masses come from, Forder and his colleagues had to harness, I don't know what harness means, 2 IBM Blue Gene supercomputers and 2 suites of cluster computing processors. Whatever, they needed big computers. We don't have time left. We have to study yoga, and here's here something else. 1 femtometer is a millionth of a millionth of a millimeter. I want to say that, I want to have the date. Okay, 1 femtometer is a millionth of a millionth of a millimeter. Okay, what is it here? A millionth of a millionth of a millimeter. I'm going to start this in camera. But I'm going to say that it's according to the book. 1 femtometer is the millionth of a millionth of a millimeter. Want to see the camera? And that was the particle physics part. If you were here for particle physics, you can go directly to the next part of particle physics. If you stay here and short power yoga, then you can stay here and participate in power yoga. If you participate in the yoga, then it's better to have feet are sitting together, standing yoga, with energy outside. Then go the arms down again. Eagle swings, in and up. Down and down. In and up. Out up to the side. In and up. Out up to the other side. and up. Inch of space between the feet, up to the side. In and up. Out, sink down. In and up. Out onto the other side. In and up. Out and down. In and up. Out, lean onto the knees. Standing cat and cow. Breathe in. Out around back, the hill. In into the middle. Out the valley or the cow. In into the middle. Out the cat or the hill. In. Out the cow. Again in. Out, come off around back up and make it to the backward shoulder. We can lift the arms up. Without elbow to the side. In and up. Out the arms off the sides, down into the chair. Breathe in, come up. Come high up. And out and up. Breathe in, reach high. Without elbow to the side. In and up. Out the arms off the sides, down into the chair. Breathe in, come halfway up. Higher up. And out and up. Come up on the tiptoes. Breathe out and sink down into full chair. Breathe in, come up. And out and down. In and up. And out the arms over the sides, down, feet together. Don't let me go. In open mountain. Breathe in, bend the right leg. Breathe out, stretch your left leg. In and change. Out, stretch your right leg. In and change. Out, stretch your left leg. In and change. Out, stretch your right leg. In into the middle. Out and down. The penguin. Breathe in, lift the right hand up to the sky. Breathe out, bend the left knee, look over the right shoulder to the right hand. In, hand down. Out and down. Breathe in, lift the left hand up. Bend the right knee and look over the left shoulder to the left hand. Breathe in, hand down. Out and down. And over pelican. Make a hand of space between the feet. Shift the weight to the heels. Breathe in and cut out. And out and up. In and down. Out and up. One more time, in and down. Out and up. Take hold of the elbows. Gently rock from side to side. And trebuchets counterweight. Hands down, feet together. Breathe in halfway up with a straight back monkey half lift. Out and down. In halfway up. Out and down. In the arms over the sides up, the having swan hands together. Lower the hands down. Hands together, elbows together, breathe in, bring the hands up the fly. Out and down. In and up. Out and down. Hands together, breathe in. Hold hands in front, bring the head. In back. Out in front. In and back. Out and down. Have the feet standing together. Cashew. Intertwine the fingers behind the back, tall up, shoulders back, breathe in. Out, head over to the side, chin down to the clavicle, pull the hands down to the ground. Breathe in, lift the gaze. Head over to the other side, tall up, shoulders back, breathe in. Out, chin down to the clavicle, pull the hands down to the ground. Breathe in, lift the gaze. Back into the middle. With stretch your fingers, intertwine the fingers behind the back, bring them over to one side, tall up, shoulders back, breathe in. Out, head over to the side with the hands are chin down to the clavicle. Pull the arm and the shoulders down, breathe out. Breathe in, lift the gaze. Head over to the other side, hands over to the other side, breathe in. Out, chin down to the clavicle, pull the arm and the shoulders down. Breathe in, lift the gaze, turn it back into the middle. Have it. Feet standing together, breathe in, lift the arms up. Breathe out, lean back, drop the shoulder blades together, with chest to the sky, a grip in the morning. Breathe in the arms up. Out and back. Down shoulder blades together. In and up. Hands together, lean back. Read in the bend. In and back. Out, lean back. In into the middle. Out, lean to the side of the the wind. In into the middle. Out, lean to the other side. In into the middle. Up across the arms, intertwine the fingers, breathe in, reach high, screw. Without reaching front, hold of the back drill. In and up. Up across the arms, the other way around, breathe in, reach high. Breathe in. Without reaching front, hold of the back drill. Breathe in, the arms up. Out, lean back with long arms for skyhugger. In into the middle. Out and lean back. Into the middle. Out the arms down. Feel its legs, breathe in, the arms up. Hold the arms down. In the arms up. Hold the arms down. In the arms up. We're doing the cactus connecting its stings of the evening. Bring the hands to touch and lower the hands down to heart center. That was a standing over, of a power over. I thank you very much and until next time.